This is a worked example on how to solve the domain of a root function. So the general process that we can use, not for every problem, but if I want to analyze a single root specifically, is I can take that root, or I can take everything inside of the root and set it greater than or equal to 0. Because if something in the root becomes negative, then the function breaks. So I'm trying to verify that this is greater than or equal to 0. And so to do that, I want to start by factoring. And so this guy factors into 1 minus x, 1 plus x. And then these will generate two zeros. I get x equals 1 and x equals negative 1. And now I can make a sign diagram. So if I draw out my sign diagram, I'm going to place 2 points, negative 1 and 1. That term negative 1 came from the term 1 plus x, which is a positive linear. So I can draw a line like this. And that term, or the 0 of 1, came from the term 1 minus x, which is a negative linear. So I can kind of draw in the other direction, like this. Now I can go through and pick my sample points and analyze. So this point is going to get a negative value from down here. And then, way up off the screen, we'll get a positive value. And so we have negative times positive, which is negative. In the center interval, we pretty clearly get 2 positive values, so that'll be positive. And then in the last interval, we get a negative and a positive, because we have a negative down here, and then way up off here, I get a positive. So we have a negative. Okay. Now, if I want to specifically grab that interval of where this guy is greater than or equal to 0, I can simply take off the positive portion, but I want to keep in mind that I can keep my endpoints because they're actually zeros. And so that interval is from negative 1 to 1, and this is exactly the domain of the original function. So that's a general process. You might need to adjust this depending on the situation, but this is a really powerful tool for looking at a specific root function and getting the domain out from it.